today's lesson is more so introducing the notation of matrices. And then tomorrow we're going to start learning about operations on matrices. So you might be like, this is really like simple, like what's the point? It's just because instead of tomorrow, for you to be focused on the notation, I want you to focus on the operations. So that's kind of why we have this lesson. So let's go ahead and take a look. So a matrix is a rectangular array of numbers or variables. Matrices is the plural of matrix. And they're going to be represented in these square brackets all the time. And are named by a capital letter like ABC. The size, aka the dimension of a matrix, is described by m times n, where m is the number of rows and n is the column. So m is rows, n is column. So it's always row, comma, column, or row times column by column. So the rows always comes first. So that's the one that people mixed up. What's that noise? So the row is the one that people always mix up because row comes first. So I always remember it because row has less letters in the alphabet than columns does, so it comes first. So a matrix is known as like 3 by 3. You see it as 3 times 3. Each entry can be described as A and then IJ, where I is the entry's row and J is beginning of the entry's column. So let me explain what I mean by this. So do you see this basic matrix here that is 3 by 3? So each of these letters these numbers represent the position that it's in the matrix. So do you see how all of these have the first number being 1, all of these have the first number being 2, and all of these have the first number being 3? That indicates the row that it's in, okay? The second number indicates the column that it's in. So first column, second column, third column. And we will use this notation to tell you which entry I'm looking at, okay? Which element entry. So entry A32 represents a value located where? In the what? Third row, second column. Third row, second column, okay? Now, the dimensions of the matrix are known as how many rows times how many columns. So it's going to be 3 rows by how many columns?
2.
It has 3 rows and 3 columns, right? The matrices. You guys see 3 rows, 3 columns? Everybody good with how I got that?
Yep.
Okay.
Yeah.
All right, next one. So for each matrix, we are going to determine the size and the specified entry in the matrix, okay? So for matrix B, what is the size of the matrix? How many rows are there?
2.
And how many columns? Good. What is the value of B22? 0, because it's in the second row, second column. 0 is, right? You see that position? All right. The next one. What is the size of the matrix for the next one?
3 by 2.
3 by 2. Yep. Thank you. So what is the value of the entry C12? So the first row, second column, which is going to be what? 11. Okay, row then column. Row then column. Okay. What is the size of matrix D?
2 by 3.
Good, 2 by 3. And what is the value of D21? Yep, it's going to be second row, first column, -1. What is the size of matrix E?
3 by 4.
Good, 3 by 4. And the value of E32?
-2.
Yep, so that's going to be third row, second column, so -2. So any questions about that aspect of it? Oh wait, you have to take the test.
Yeah, can I take it tomorrow? Friday?
I'm not going to be here tomorrow, so you guys.
Thursday.
Okay. All right, next one. A survey was conducted in an English and math class to determine which type of ice cream was most popular. In the English class, 15 students prefer strawberry, 8 students prefer chocolate, and 3 students prefer vanilla. In math, 9 students prefer strawberry, 12 students prefer chocolate, and 7 students prefer vanilla. We're going to write and label a matrix that represents this data. So I want to make sure you know this before we get into it. So we have the categories vanilla, chocolate, strawberry, and then we have English versus math, right? So automatically, I know the matrices are going to be 3 by 2 or 2 by 3, right? So you can actually represent this data two ways. You could do the vanilla, chocolate, strawberry on the top as the columns, or you could do it as the rows. So I'm going to show you how you could represent it both ways, and these would both be correct representations of the data. Okay, I just want to make sure you guys are aware of the fact that there's multiple correct representations here. So the first way you could do it is you could do vanilla, chocolate, strawberry as your columns. And if those are my columns, what are going to be my rows? English and math. Now you can use abbreviations, but keep in mind if you do use abbreviations, if anything starts with the same letter, just make sure you give it a few more letters so we know which one you're talking about. So in English class, how many people preferred vanilla? 3. In English class, how many people wanted chocolate or like chocolate? And then strawberry? Good. In math class, how many people prefer vanilla?
7.
Good. Chocolate? And strawberry? Good. So this is one correct way to represent, and this matrix would be 2 by 3. Now you could also correctly represent this data by doing the vanilla, chocolate, strawberry as your rows and the subject areas as your columns, right? And that would be 3, 8, 15, and 7, 12, 9. So everybody see how there were two correct ways to represent the data. Now the number of elements in any matrices is always the product of the two numbers, the dimensions. So as you can see, there's 6 elements to both of these because 3 times 2 or 2 times 3 is both 6. So if I ever ask you the number of elements in a matrices, that's the easy way to find it. All right. Next one says, given the table that represents the cost of 3 different lunches that are sold at an elementary school and how many each lunch was sold in a single day. So how much money did the cafeteria collect selling all 3 lunches? So if we sold 55 of lunch 1, 90 of lunch 2, and 70 of lunch 3, how could we figure out the total amount of money that we made? Multiply and add. So the price of the first lunch times the number sold, plus the price of the second lunch times the number sold, plus the price of the third lunch times the number sold. And if you do that math correctly, you're going to get $475. Okay? Now it says write and label a matrix that represents the cost per lunch, per each lunch, and the number of each lunch sold. So I'm going to make these two be my rows. You could also do them the columns. So I'm going to do cost. And then the next one I'm going to do number sold. And then what am I going to do on the top? Label them. Good. Lunch 1, 2, and 3. Okay. You can do L1, L2, and L3 if you don't want to mix them up with the numbers. So what is the cost of lunch 1? $2.50. This one's going to be 2, and this one's $2.25, right? The number sold is 55, 90, and 70. So all we really did here was we converted data from a table into the format of a matrix. Okay, not really anything too out of the ordinary here, but you do have to understand the difference between the two types of representations. Matrices do not have lines in them like a table does, okay? So for the next one, write and label a matrix that represents just the cost of lunches. So this matrix here is 2 by 3, correct? This one's only going to be 1 by 3, right? Because I'm simply eliminating the sold number in my matrice. So I'm just doing just the cost. And then write and label a matrix that represents just the number of lunches sold. What's that one going to be? 1 by 3. And it's the same idea as this one, but instead of cost, we're going to do number sold. So 55, 90, and 70. L1, L2, and L3. So does anybody have any questions about this so far? Okay. So this one says a marching band, dance team, and theater department at Northport High School need new equipment and uniforms for next year. The marching band estimates they need $800 worth of equipment and $1,200 for new uniforms. And then they just go through the dance team's equipment and uniform prices, and then the theater department's estimated equipment and uniform prices. So I need to set up a matrices that can represent this data. So how many correct different matrices could I have here? Yeah, I mean technically I could rearrange stuff, but yeah, I could do a 2x3 or a 3x2, right? So I'm gonna do it like this. I'm going to do let's see, we need equipment and uniforms, and then we have the marching band, dance team. Just one sec. Hello? Yes. Bye. Ariana, you're being dismissed. And theater. And then we're going to label them or put them in the right spots. So we have the equipment, and then they have uniforms, and then we have dance team, equipment, uniforms, and then we have the theater department, and then we have uniforms. So this is one way to represent the matrices, but you could also have represented it the other way, right? You could do this over here, and you could do this up top. And that's pretty much it. You probably get the idea. Now there is one thing I want to mention to you guys before you do the homework. There is one question about profit. So I just want to remind you or let you know what profit is. Profit is revenue minus cost. So basically it's sold price minus cost. Okay, I put all the information in the key if you need to see it.